Day 18 of 365, and today we're going to look at your network the way an attacker does. You can probably name the devices: router, switch, firewall, proxy. But here's the question that actually matters: if I compromise each one, what do I gain? And if I'm defending it, what log do I watch? By the end of 5 minutes you'll map every box in a real topology to one attack path and one detection rule. Let's go. Picture a small enterprise. ISP router at the edge, then a perimeter firewall, then a core switch, off that a DMZ switch with public-facing servers, and your workstations hanging off the core. That's the path every packet travels. Each device makes a default trust decision, and attackers live in those defaults. The router trusts whatever the ISP hands it. The switch trusts every port in its VLAN. The firewall trusts traffic that matches an allow rule. Memorize the topology, because the topology is the attack surface. Start at the router. Its job is forwarding and NAT, and its weakness is routing trust. If an attacker injects a bad route or poisons your ARP table, traffic silently detours through them. On a Cisco-style device you'd run show IP route and show ARP, and you're hunting for one thing: a default route or next hop that shouldn't be there. A gateway pointing at an unexpected MAC is not a quirk. It's a man in the middle, already in progress. Now the switch, the device everyone forgets. A managed switch sees every frame on its VLAN, which makes it the best detection sensor you own and the best pivot an attacker can grab. The catch? By default it logs almost nothing. One line fixes that. On the switch you point syslog at your collector, logging host 10.0.0.5, and suddenly MAC moves, port flaps, and table overflows become events you can alert on. An unmanaged switch can't do this at all. That's why attackers love them: pure blind spot. The firewall is your obvious control, so let's actually read it. On a Linux box running tables you run nft list rule set to see exactly what's allowed, and you check whether management ports are exposed where they shouldn't be. Then you read the logs. Here's the triage one-liner a junior analyst runs during an incident: awk, the syslog for connection attempts, then sort unic, csort, rn, to rank source IPs by volume. The noisiest source hammering ports 22, 23, 443, and 8443 floats straight to the top. That's your scanner. Don't forget the proxy. It sits between users and the internet, terminating and inspecting traffic. Its trust assumption is that internal clients are friendly, so a compromised workstation uses the proxy as a clean, allowed tunnel for command and control. The defensive win here is visibility. Proxy access logs show every URL every host requested. A workstation beaconing to the same odd domain every 60 seconds doesn't show up at the firewall as anything special, but in proxy logs it's a flashing red pattern. Let's make this concrete with enumeration. Before an attacker targets anything, they map a few lines of scapy fire ARP requests across A/24, collect who answers, and bucket each MAC by its OUI. The vendor prefix tells you Cisco gear from a Dell server from a random IoT device. 3 minutes of passive scanning and they know exactly which box to hit. The defender's move is the same scan run on a schedule: a new MAC that nobody provisioned is a rogue device, and now it's an alert instead of a breach. So here's your mapping. Router to a route change alert. Switch to syslog MAC move detection. Firewall to that port hammering unit count. Proxy to beacon pattern hunting in access logs. Every device is both a control and a pivot. Your job is knowing which role it's playing right now. Day 18 done. The takeaway: defenders win when they turn each device's logs into one specific detection rule. Subscribe for day 19.